Welcome back here at the Technical Forum at the group exhibit Hydrogen, Fuel Cells and Batteries. We are here at the Hanover Fair in the year of 2016. At this time, I invite you all to come and have a seat, have a drink, and enjoy our next presentation. Also, I would like to say hello, welcome to all our online guests. We are live streaming from the fair. My name is Mona and I'm the moderator here. Our next topic will be on lithium-ion battery simulation and emulation. And for that, we'll hear a representative from the Fraunhofer-Institut for Windenergie and Energiesystemtechnik. So please welcome with me on stage Mr. Christoph Kettenring. Big hands, please.
Yeah, welcome, ladies and gentlemen. I come from the Fraunhofer-Institut IWES in Kassel. I'm in representation here for my chief of the department, Matthias Puchter. I tell you something about lithium-ion battery simulation and emulation. The modeling process for battery simulation is the first part of this is understanding the problem. Then you need a modeling approach. After you understand this and you have an approach, you develop the model. After the model developing, you simulate your model, and the last step is a comparison with measurements on a real cell. If the measurements are right and we have a good result, we have a complete model, and if the results are not so good of the simulation, we go back to the development and try to find our mistake. First, we have to understand the problem. Lithium-ion batteries are a highly nonlinear system between the voltage and the current. And we have a strong influence on the terminal voltage by the state of charge, the age, the calendric age, and the cyclic age. And we have the ambient temperature and also a temperature in the battery pack later. And we have many different cell chemistries, for example, NMC, LFP, or LTO. There are some different modeling approaches. We speak about 3 different modeling approaches. We have first the black box model. The black box model is a neural network or a fuzzy logic, and it's good because you have a very high performance in the simulation. You need not so much knowledge about the whole battery system, but you also have some disadvantages. You have no parameters with a physical meaning. You have a low insight in the model during the runtime, and you have only input and output behavior of a certain battery available. The next model is a gray box model. That's another type for beginning to make a simulation model for lithium-ion batteries. The advantage is also a high computational performance. You have some physical meanings in the model, like the resistance in the battery. Oh. The disadvantages of this modeling approach is you have a linear model for a nonlinear system, and only an input and output behavior of a certain battery available. We take at Fraunhofer IWES the third modeling approach. It's a white box model, and it's an analytical model which needs a theoretical analysis of the battery. All the parameters have a physical meaning, and during the simulation you can look inside the system. The system has a very high precision, but you have the problem the computational problem, because you have lower performance with this model. And you must know very much about the battery system and the chemistry and the physical meaning of all parameters. With this modeling approach, we go to the model development. For the model development, we have, as an example, EZlib, our software. The goals of the software is high precision over the whole range of operation, and there are no we need no measurements from the user, and you can look inside the system during the simulation. And the whole system is, you can use this battery model in real-time systems. This is white box model, and it's a non-linear model. And the structure of this model, you can see here. You put in the current, you get out the voltage and the internal quantities. But and in this model you have the state variables, and these state variables need an internal with an internal state. In our software, you can put the initial state through a graphical user interface. You can start, for example, with a state of charge in percent, and you can say we have such an ambient temperature, or you can start with the electric density or the positive or negative lithium-ion electrode, however you want. In the model, we have the model parameters, characteristical model parameters, and constructive parameters. We have a look to the constructive model parameters that are, for example, the geometrical dimensions, morphology of electrodes, the layer thickness, the electrical connections, and the rated values. All these things you can configure in our software for the white box lithium-ion battery model. If we have done all these steps, we can start a simulation. With our software, it's possible to simulate in MATLAB, or with real-time Unix systems. It's also possible. The graphical user interface, which you see on the left side, there you can see the lithium-ion concentration inside the positive electrode, and you can configure all parameters in the software. Then you can start the simulation, and I brought some results. For example, we check the measurement and the simulation. which we done, for example, here with different temperatures, and you see it's very exact between the measurement and the simulation. On the next slide, you see also a result of a simulation. We simulated a discharge with a current of 100 ampere and a charge of 25 ampere, and you see the simulation with different temperatures. You not only can simulate with our software, you can, with a real-time feature, you also can connect it to an emulation. For example, in our test center for smart grids and electromobility in Kassel. Normally, we have the battery and an electric vehicle, and we can drive with this vehicle, but we have no view into the battery pack. Yet we can take our battery simulation, connect the simulation, the real-time simulation, to a voltage source, and we get the current and the voltage as an output. We can connect this to the electric vehicle, and we can drive tests on this test bench, and we can see all the states in the battery pack. You think about why we do this. We can make some tests in a very short time, because we can set the initial parameters of all the cells in the battery pack, and also the ambience temperature, and how the pack is built up. There are also other applications. We have a battery management system test environment with about 100 channels. We simulate the cells in the battery pack with each with thermal and electrical connections between the cells. And in the middle, you can put the battery management system, and then you can check if the algorithm of the battery management system works correct, or you see the SOC and the SOH of each cell, and you can compare it with the results of the battery management system of the software. Yeah, lithium-ion battery simulation, emulation accelerates development. If you want to know more about the theme, come to me on booth E41, and we can talk about battery simulation and emulation. Thank you.
Thank you very much also from my side. That was a really interesting presentation. You can take all your questions to booth number E41. Mr. Kettenring will welcome you there at the booth. Thank you very much.
Okay, thank you.
Our next topic will be an update on AVL SOFC and SOEC fuel cell engineering, and that will be only in 2 minutes' time. So please stay seated and have another coffee. Thank you.